Good morning, everyone. This is Taylor Saul, Account Manager with Applied CAX. We sell and support Siemens NX CAM and CAD products. We have 30 engineers on staff and only 3 sales guys, so clearly our focus is on providing the best support in the industry for Siemens NX CAM products. We are the most technical Siemens partner in the country, ensuring that our clients are getting the most out of their investment in digital manufacturing. We have a prototype machine shop on site, running both 4 and 5-axis machines. Some of the ways that we help NX CAM clients around the country are NX post-processor development and optimization, configurable NX training classes, NX CAM environment templates to ensure standard processes are developed and utilized in our shop, and sales and solution development for Siemens NX CAD and CAM software. We appreciate you all taking the time out of your day to be here. If there's anything we can do for you, please don't hesitate to reach out. Thanks, Michael.
Thanks, Taylor. Morning. Hope everybody has their coffee, get their morning started right, or your drink of choice. Let's get this going here. So here's just a little bit of overview of what Taylor was talking about. We're here to help you, and we use the software day in and day out. So I think that puts us in a unique position to know what you need help with and to be able to relate to getting through those questions you have. A lot of the things you'll run into is stuff that we have in the past and that we've worked through, or we're always trying to stay ahead. So we're usually testing the latest technologies and new releases, of course involved in the beta testing year to year. So looking ahead at what's coming up and also trying to drive what will be implemented into the software for our customers. A little bit about me. I've my background is mainly starting with design, product design. About the same time I started that, I set up a mold making and injection molding shop, and I was responsible for purchasing the software and equipment, but also product design, mold design, doing the CAM. And then when the mold was done, I would end up programming the injection molding machines and robotics. Of course, that grew into, in some situations, training others, but several of the businesses were, under 200 employees. So sometimes you just had to do what it takes to get the job done, and I enjoy that. And yeah, so I'm very familiar with kind of the end-to-end and the effects of, the challenges that you'll run into due to product design that might not have design for manufacturing in mind. And also I think my experience would help in any stage of your production. So also, used many CAM systems. I've used like 7 different CAM systems, lots of different CAM systems, and that's helped me understand what's good and what's bad. And also, I think one of them in particular that I got was, it was a spree, and it was definitely more expensive. And I was not happy with it and ended up returning it. And that was about the time that I was at a U.S. digital and encoder manufacturer, and we had all types of machines, wire EDM, verticals, horizontals, screw machines, mill turn. We just had, everything. So I was looking, like you, I was looking for something that could do it all. I didn't want to have multiple packages, transferring files in between and worrying about translation. I wanted one software package that would do everything, handle the different machines, and that was about the time I came across NX, and that's where I got started and was doing mold design and everything in NX. And actually the cost was lower, the capabilities were definitely better, and it was nice to be able to do everything in one. So that was where my love for NX and kind of my foundation for NX started. And so I was once on the customer side and having people do demonstrations, and so being one that is involved in doing them now, I know a little bit better what you're looking for, and I understand your side of the business. So I've been here since 2011. Set up a prototype shop here. We now have grown a little bit. We started with a little 3-axis or 4-axis vertical, and now we have a 5-axis DMU 50. We push it. We're always trying to learn new things. We've definitely done a deep dive into the 5-axis and the Siemens control. It's been fun. I don't think I'll ever go back to 3-axis. 5-axis is amazing. It's nice to be able to shorten tools, and if you don't have a special cutter, you can usually come up with another way to access that hard to machine area, and it just gives you more flexibility. So I've really enjoyed having a 5-axis machine. Our experience here, or what we do here, is more prototype. Complex parts all over the place. Not necessarily one type of product. So we definitely, we do anywhere from vacuum molds to complex fixtures, and just all, aerospace. We cover pretty much all the industries. So that definitely helps us see, the different challenges. And keeps it fun. One of the fun projects I've been working on lately is taking a vacuum mold that someone else made, and it needs modified, and doing CMM and then doing modifications on it. Not everything's designed on it, so having to add features, and also finding that some faces are off as much as 40 to 50 thousandths per side, but able to finish that up with just matching everything up. And I'm really enjoying that. I like facing new challenges. So I'm not an expert in everything, and I definitely learn from you guys all the time. Keep an open mind. So I'm not here to tell you there's only one way. I just like to share what I know, share my experience, and hopefully you get something from that. And it's always great to brainstorm. So anytime you have deeper questions, or you want to just look deeper into your situation, definitely reach out to us, and we can partner with you and work through it. So what I see as the advantages of multi-axis is, like I said, shorter tool, which allows for faster feed rates, reducing chatter, also just flexibility. Some of the disadvantages, if you do you have to keep in mind, if you're doing, like, say, several fixed axis or plane orientations when, so 3+2 machining when machining, that can have an effect on blending, depending on the accuracy of the setup and the accuracy of the kinematics on the machine. There's just a lot of factors, so definitely that's one of the disadvantages I see. So that's having multiple fixed axis tool vectors. So what we do, we tend to do in that situation is we try to have the toolpath that we want to have adjust to blend. We would like to adjust the toolpath that might be quicker and less machine time. So if we have a small ball mill cutting a radius, a larger radius, and it's a lot of step overs, but then a face mill might be doing a face that blends with that radius. We'll do a length compensation on the face mill until it blends, rather than continually running the longer tool path. So that's kind of some of the tricks we use. We're using mostly length compensation, and working on implementing the 3D compensation for 5-axis. So important factors when machining full axis, keeping your machine kinematics in mind, for blends, and also for gimbal lock, situations where you might only have, like in our situation, our B-axis only rotates -5 one way, and that's our table. Our B-axis table only goes -5 degrees in one direction and 110 in the other. So we tend to try to program beyond 5 so that we don't get it switching back and forth. You get kind of some dwell marks possibly, and some just your movement's not as smooth. But yeah, I mean, that's pretty much all I've got for the slides. I know how much people enjoy slides, or how much I enjoy slides, but just wanted to give some important points there. So one of the challenges in demonstrations is finding. We have some really cool projects we work on. I'd love to be able to share, but customer products. So I tend to go out to GrabCAD and look for some non-licensed models that I can share, and then I can modify them from there, of course, with NX. So here I've got a mold with some deep pockets, small radiuses, hard to reach areas. But there's certainly situations where you would also use this on something that's your movement's outside of a cavity, maybe a core or a aerospace type of part. But here, as you can see, I have it set up in a simulation kit. So this is a sim kit attached to the setup file for NX. So this has the kinematics, the post all attached, and they're communicating with each other. And this really improves, the way that it resolves kinematics and shortest moves. So this is G-code simulation. It's not simulating the internal code. And just to show for those who haven't seen it here, a little movement. So you got all your kinematics movement here in this particular kit. This is a table, so both rotaries are on the table. It also allows, NX also allows you to look at your movements prior to doing a toolpath. So some people find this helpful for looking at your tool length and what tool might be best to get into a certain area. So here I just double-clicked on a tool in my tool navigator where I can see all the tools I have assigned to different pockets of the machine. And as I drag this around, the machine's actually moving with it. So if I wanted to see, what it might look like, I'll hide it for a moment to get down in here. Of course, this isn't the cutter I would use, but it just gives you an idea of, hey, is my holder going to have any collision issues? A tool long enough? What size of? It just gives you some diagnostics to look at, and this might be handy even for quoting. Setting up this file in here, it can be a template, so it's not difficult. So if you're not familiar with kind of that part of NX, certainly let us know, and we can demonstrate more about the simulation kit, as we call it. But that's not what I'm really getting into here. Just wanted to get a little short overview. So here we'll just we're going to look at different ways of creating your multi-axis tool vectors. We've got this closed half-open pocket here. It's got a little bit of it. It's got the wall there with a small radius. So this is a little bit challenging to reach, certainly in a case of maybe a 3-axis machine where your cutter is going to be much longer. You're going to want a smaller radius, probably a ball mill to be able to go up that wall. So a 5-axis can be handy in this situation, just to be able to tilt. You could resolve this with a fixed machining where you just tilt enough to get your holder away from the wall and then work it down. So I'll kind of start there, and then we'll dive into the full 5-axis. Kind of work our way down here. So I've got this set up so that we don't have to go over roughing. I've just got the part set up of course, it's seeing the 3D geometry for the part, and then for the blank, I just have offset from part, kind of like if you had gotten a casting. So here, what we normally do in this situation is we'd work it down with a ball mill, and then in the end, we would do a smaller ball mill tilted until we get that blend down. Of course, with the if we had to work that down, let's look at what size that is. So a 32nd. So, if we had to work it down to a 16th, that's a situation where we wouldn't use fixed axis. But I use fixed axis wherever I can, just because your speeds are going to be faster. You're not having to sync all the different kinematics, the tables or the rotaries. So wherever we can do fixed axis machining, 3+2, we do that, and then use the multi-axis as needed. So I'll go ahead and choose the, we'll go with the 1/4-inch ball mill to start with. Expand them out here. Alright, so looking at the length, I thought it looked okay. We've got 1 and 150 thou inches, so 1.15 inches. So we'll go ahead and use that, and we'll just use an area mill in this case. So I'll go new operation under contour, and we'll pick fixed axis area mill. I would use a streamline because you have nice flow curves here, or you could use just a straight area mill. We'll try the area mill and see how that works on this one. So we'll pick our cutting area, and then we'll go ahead and set the tool axis. So under tool axis, you can specify a vector, and then you could select curve or faces. I'm going to go ahead and use dynamic. And so now you could just select, this is kind of the thesis here. You can select a sphere and move it closer to what you're machining, and then you can tilt either by dragging the tilt vector, or you can, if you select that sphere there, you can enter an angle. So I can enter 30 degrees and try that. You can actually, and I find this kind of cool, in some situations you can set it to the view that you're looking at. So you can go to specify vector and just say, my view direction. So if I'm looking like this and I select that, now you'll see the vector here. There we go, I reversed it. So it's just what angle I was looking at it. But in this case, we'll use dynamic, and we'll set it to 30 degrees. Another trick I use when I'm setting vectors, just so I have some kind of, not in every situation, but in some situations, I like to have visibility to what vector I have it set to, and be able to adjust it without going into the toolpath, or if I'm going to use that vector again, I have something to reference. So I actually add a datum thesis. So under the center area, you have datum thesis geometry, and I just go ahead and add a thesis that brings in your vectors, planes, and actually a point at the datum 0. And so now if I set this to 30 degrees, and I go into my toolpath and say specify vector, I can select the Z and then generate. Of course, my step over right now might not be ideal, but if I go and change that vector, and I say, I want less 5 degrees, so now I'm at 25. My toolpath now needs regenerated, it realizes that there's been a change. So this is actually changing the vector inside the toolpath. So that's one trick I use. I try to use geometry whenever I can, so I have history and I have something to go back and troubleshoot if there's any issues. Not something that's hidden inside the toolpath, but something that's actually a feature. I find this also handy for mirroring toolpaths. That way, if I've had certain customers have issues with mirroring and they didn't have any way to really diagnose, what caused it because it was internal to the toolpath. So they were working on a large Pelton wheel. So by switching to this kind of system, they're sure that it's going to be relative to their system coordinates, and they also have something they can go back and troubleshoot if they have issues. So as you can see here with area mill, it doesn't follow, the geometry. It doesn't do a great job of that because we have so much curvature. Even if I set it to something like follow periphery. So go ahead and generate that. You get a little bit of an interesting pattern. I mean, it's definitely, with NX11, this has been improved so that it will clean up these areas where you're getting different step over amounts. So here we've gone and cleaned up those areas, but that's why an actual something that uses the flow curves of the geometry can be much better. So for comparison, we'll go and use a streamline. And I am going through this, rather quickly. This is kind of geared towards people already using NX, and for those who haven't, you can get more familiar with the tools, but you might need kind of a deeper dive into, how did you do all that? So we'll go ahead and with the streamline, it creates some cross and flow curves. So it really follows the shape of the part well. And you can also have it extend off the edges. Let's look at the toolpath here. So you can see, we're going up beyond the geometry right now. You can smooth these rapid. What I tend to use is under smoothing. I like to have both the engage and retract and the transfer set up with smoothing turned on, and so it just does a little bit better job of eliminating and creating smooth arcs. You can also I can see that this goes up a little higher, so it's trying to machine up in there. So there's a couple different ways to actually create the projection vector and the way that it creates or projects the toolpath to the part. So I switched to on. Tangent to can cause issues when you have small areas that are smaller than the cutter. And what I would say is when you're, I don't have time to go over all of the specifics, but I will say that the help is great. If you want to see more about like this area here, as far as the tool position and what that all means in regards to on, tangent to, and contact, if you just simply select F1 while in NX, it'll open up the area of help that relates to what you're doing. Sometimes it might not be on the exact page, but in this case, it is. It's there are certain situations where the topic will be a subtopic because there's a lot on that particular dialogue. But here it kind of talks about the on, tangent to, and contact. And then there's a couple others I saved that show some great diagrams. So this was created from NX help. So definitely go in. This one's called tool position. So if you search NX help, it's a little bit better quality than when I converted it, but it shows kind of what all the different tool position methods, how they affect the toolpath and what's best to use. So we'll go back here. As far as projection vector, I tend to use normal to drive and towards drive. Towards drive is good for cavities, and normal to drive is good for like outside surfaces. All right, so let's get down to it. Let's do a smaller tool on this. So we'll say OK. And you know, we can look at, let's see where this operation's at in regards to others. So if I was to, I can look at, you know, what my material removal situation is just by clicking on Show 3D IPW. And so this kind of gives a quick preview of what we've done and what's still left to machine. Another way to look at that, of course you can do that with 3D Verify, but these are just quick tools I use while creating toolpaths because, you know, I tend to not do the really deep analysis until I've kind of got the toolpaths laid out in the order that I like, and then I'll start diving deeper. But as I'm creating them, I like to use this tool in order to just have a quick picture of what material's left, and you know, so I can click on the faces and see what I've got left. So I'll just say OK, and obviously we need to have some radius material here to clean up. I kind of skipped the vertical wall because I just want to focus on the multi-axis. So if I wanted to go back to this, I would just copy and paste, and then we would just it looks like I didn't set the tool axis back here. There we go. And so now if I preview that, you can see that it's tilted away. And then in the worst case here, we can look at if there's any collision, and there isn't. So we're allowed, this, you know, definitely helped us. We could even shorten that tool more, tilt more, but I just kind of want to move quickly and keep this going. So the one I copied here, it didn't have the tilt, so I'm going to delete that and recopy the toolpath. And then we'll just change the cutter. Of course, you would change the step over. I have this all doing finishing. You would want to step that through like semi-finish, finish. Oh, and the other thing I would do, sorry, is limit the area that I'm machining. So in Streamline, as long as you know where you're starting, so I'll say I'm starting out here, you can do a trim. You can also have it recognize what material's left, or I could just select the fillet area. What I tend to do is, and I can actually show that real quick, the tip I'll show is kind of adding a trim, a division line on the actual face. The reason I do that is anytime you're adding like 3D, if you're adding like the ability to look at rest material, you're adding time to your toolpath generation, and I know everyone, all of us like to keep that low. So what I tend to use is like creating some curves on the face. Might not be able to do it without going into, there are ways to do it without going into modeling, but the tool I tend to use is inside of modeling. One of them you can use is, let's see here, sorry, I'd be under curve, offset, curve, and face. You just pick your face that you want to offset, and then oh sorry, pick the curve. We'll extract, you'd have to extract the curve first. Alright, let's see. So I'm clicking on extract curve, and then we'll go back into offset curve and face. I'm going to pick the face but not tangent. We just want to pick single faces here. And then the curve we want to offset. And then you can just drag it to, what I tend to do is, you know, whatever, let's say we used a 1/4 inch, so we'd want to go out like 135 and start there. So I just extracted, get a little nervous sometimes during the webinar and stumble, but just extracting the curve there with extract geometry, and you could certainly bring that to out onto your toolbar, but then you just set the distance, and when you say okay, you have that curve there, and you can pick that as a trim, or you can divide your face and then just pick that as the divided face. So if we go to divide face, we'll just do one of them here and pick the line. Pick a long vector, and then we've got a separate face there. So we use that, or you can use inside of the toolpath itself, you can just use the trim amount. So inside of streamline, you can set your trim and then generate. And you'd want to go along the other vector, but you can trim it in either way. You can trim it along the U or the V. Alright, so if you want to do this multi-axis, we'll do a full, you know, if you want to do a small cutter multi-axis, I would do towards line, so we'll add that. So we'll go to mill multi-axis. We'll go ahead and use the same cutter. And then we want to do projection vector still towards drive, and tool axis, I'm going to say towards point. I'll come back to that. I'm going to go ahead and move that datum or add another one here. I'll hide the one that we added. So we'll try, you know, something like that. You can also do it by a distance. So we'll pick that point there, and then pick our surface to machine. With the surfaces, I would put those in a geometry group so that you don't have to keep reselecting them. It basically is like a container. When you drag operations under it, it knows what faces you want to machine. So that with that method, you would only pick the faces once. And then we'll set our step over. Zigzag would be fine. And then next we'll cover a little bit of contour profile. So I could have done a smaller step over to kind of troubleshoot this, but you know, just to make sure that our tool vectors enough. So I would actually have that steeper. So we'll go ahead and set that up a little higher there. And then regenerate. So now you can see you're getting a little less tilt. So yeah, you have a lot of control and visibility to where you're tilting to. If you wanted to move that by an amount, when you double click it in your tree, if you just click on one of the cones, you can say, you know, I want to go up an inch, or I want to go down an inch. You can also set it a distance from your absolute or from your work coordinate system. So there's ways to do that rather than just dragging it around also. So that is a variable streamline with towards point, and then the projection vector is towards drive, and the drive method is streamline. So down in these deeper pockets, we'd want to look at the radius, and then I went ahead and made this an undercut, and like I said, I downloaded this and did all the changes in NX. So just a quick, looks like I created it into a body, but yeah, these came in without being undercuts, and I was able to use synchronous modeling to create those undercuts. So if I wanted to analyze the radius, just click on it there. You know, it's about an 1/8 inch radius, so 1/4 inch cutter would work. I tend to like those over the amount of the radius of the cutter though, so if I'm using a 1/4 inch cutter, I would set the radius at like 135. So we can go ahead and do that using synchronous. I know some situations you're not going to be able to do that, but this particular blend is a B surface, so I need to convert it into a non-B surface. So while I convert that, I'm going to go ahead and change the size of it. And so now we could use that 1/4 inch. I've done it before with also a 3/8. So we'll go ahead and, I think I do have the 3/8 in here also. All right, well, we'll use the 1/4 inch. All right, so we'll create a contour profile. This is a particular toolpath I use often. Nice and easy to generate it's probably the easiest to create a 5-axis toolpath. And so under mill multi-axis, you can see this contour profile. With the method here, I usually set different methods with different tolerances. Basically, and that's what those are reflecting, is the tolerance level. I find with smaller cutters, I go to a tighter tolerance, and then our DMU50 takes and converts that into smooth splines if it's a point-to-point toolpath. All right, so we'll go ahead and pick the floor, and then it will automatically pick the walls. Other than that, we'll just generate it. And so right there, we already have a multi-axis toolpath. One click. So it's tilting. It's obviously too short, so we'll extend that cutter. And if I had to extend it, let's look at the depth there to see. So one way to, when you do analysis and to keep the dimension associative and be able to see it without having to measure again, is to use the PMI, product manufacturing information. It's like 3D dimensioning. So if I pick those two faces, I can just set the dimension out to the side. So we have 1.339 as our, so it's not too bad length ratio. I mean, it would be nice to be able to go up a size, but we'll just go ahead and extend that cutter. So I can select on the bottom surface. So I just double click the tool. I'm not in an operation, and using that same thesis that we're seeing over and over again, you know, I can drag my cutter around. I can make it relative to a point on face. I can tilt it relative to like a curve. So you have a lot of control for analysis. Yeah, let's go ahead and tilt it. All right, and then I like to switch to wireframe. We'll look at a normal view here. So while I'm looking at it in that view, something like 1.4 inches. Of course, we'd want a longer flute length. I would go up to 3/8 in this case, but which is easy to do. And then we'll extend the flute length. There we go. So we'll try that. I'll rename this. Of course, I'm shortcutting here a little bit. All right, so we'll go ahead and regenerate that. It knows that I've just changed the cutter. I'll go ahead and update that blend, so I can just highlight it and go to details and change it here. And then generate again. Generation times on this type of toolpath are very fast. And then we can kind of, you can either replay it. Of course, you can turn on collision detection and all that, but that's a little tight. But that's tends to be how we program here. We definitely run as short as possible, but it looks good. And then if you wanted to do that in steps under cutting parameters, you can go to multi-passes and you can set your depth. So that depth was let's say 3/4, and let's say we wanted to do that in 3 passes. And then of course you could do side passes also. I will say, when we get into very deep pockets, maybe 7 times diameter, depth to diameter ratio, we've had issues using this type of toolpath in the corners, especially if the design is, like say a long 1/4 inch cutter and the corners are 1/8. They're exactly, half of the cutter. What I probably should do is try a metric or something that's not an exact. It's just too much contact when it gets into the corners, so we get chatter. I've experimented with really, smaller step downs, like maybe I think I did 30 thou step downs, which is still much faster than doing it just not normal to the wall, just normal to Z. Well, of course, an undercut you couldn't do, but I'm talking about normal drafts, inward drafts, or positive. It'd certainly be faster than stepping it down 2 thou at a time, but I had to just keep the job going, so we ended up doing a normal step down, but that's something I'm going to continue to experiment with. So here we've got the depths broken up into different moves, and then again I like to, I would set this up in my template or standard so that I don't have to keep setting it. You can set it as kind of like your default. I would set up smoothing, and what it does is just kind of smooth arc in away from the wall. Works great, really easy to set. All right, so then so that's a little bit about the contour profile. Great operation. I also, so in this case we had a floor. If we didn't have a floor, and that was like a a through pocket, which let me show that here. So we'll just slice this momentarily here. Oops, did not mean to do that. So I've got it kind of shortened there, and then if I do something like, let's delete these blends. All right, so we have a through pocket now, no floor. So in that case, what you need to do, because now your floor is gone, is you would use automatic auxiliary floor, and then you'll see it generates. Let's generate it here. Oh, the automatic walls didn't work because it didn't have a floor, so now we have to select the walls. I don't think the negative draft continued, but I'll just do the upper section. Yeah, the negative didn't continue, so I'll just use the upper section there. And then you can see it created a floor, and then in that case what you can do is that floor can be moved, so that's nice to be able to go beyond the bottom of the wall. And so then when you generate it, in this case without the negative draft, I'm not sure, yeah, it still went down there. So yeah, so it stopped. Oh, I didn't go far enough. Yeah. Yeah, it sees the wall is not normal to, we can fix that. Well, actually, we can just bring the bottom of the mold up to that, so let's do that. Let's say there's a plane. All right, so I'm just hacking away here. I don't have several models. I like to keep to this one just because it's not a customer part. So now if I generate, I don't think I have collision on just to keep the toolpath generation, but you can see we're going beyond the bottom there. So it automatically can create an auxiliary floor. I really like this toolpath for even upper sections that aren't continuous. To go up. I've had situations where maybe the top section I could do a normal to the wall, and then the lower sections were broke up enough I couldn't, but at least I could do the upper portion of the wall very quickly with a contour profile. Another toolpath that's really good is surface.
I'd like to go over the multi-axis surface area contour toolpath. What this toolpath offers that's unique is the ability to drive the multi-axis tool vector based on the drive surface. So on a part like this where you have steep walls that are joined by a radius, whereas if you had normal to surface, obviously when you're up on this surface, the normal would be facing the other side and you'd have a collision. A part like this you couldn't have, normal or away from point, because that won't cover the entire area that you need to cut. Relative to vector wouldn't allow it to follow this. There might be ways that you could come up with one that sort of works, but on this type of part, a good tool to have is the surface area. So I wanted to show how I derive the surface from this part. There's a couple different ways. I'll hide what I've previously done here. So I'm going to use the extract tool. I'm going to go ahead and go into modeling and extract geometry using the extract geometry command. I've also added it here to my toolbar or ribbon bar. So on the composite curve command, I can go ahead and grab these edges, and now I've extracted a curve from those edges. And the reason I'm going to do this is because it follows the shape, natural shape of the part. This part is revolved around center and also has this curvature on the top. So if I revolve a reference surface uh, about center and kind of follow the shape of the part, I'll get a better tool axis. So now that I've got that, I'm going to use the extend curve command and extend the top of the curve a bit. So I could just pick the curve and drag an arrow. I'm going to drag it up beyond the area that I'm going to machine. Then you can see that the curve's going up into this area. So now from the home ribbon bar, I'm going to, under extrude, do revolve and pick those curves. And then for the revolve vector, I'm going to use the datum coordinates, in this case the absolute 0, and it happens to have a datum thesis. So I'm pretty happy with that. I just need to be revolved beyond what I'm cutting. The other thing you'll notice here is the shape of the reference surface follows the shape of the part, which will give us a good toolpath shape when doing zigzag. So I'll say OK. I'm on solid and none, so this will create a surface. I'm going to go ahead and hide the main part so that we can see this surface and easily select it from manufacturing. So I'm going to use the variable contour command. I've got a little placeholder here. This would be, if you want to know where you get this from, it'd be under the mill multi-axis type. And then you could choose either this, probably the streamline would work just fine, or the contour, and either one of those, once you select them, the drive method could be set to surface area. So going back here, we have, we'll go ahead and start with picking the surface area, being that we went ahead and selected to hide our main body. So I'm going to go into specify drive geometry and pick this reference surface. So it'll be 3 surfaces or faces. And then before I exit this tool, I'm going to pick my cut direction, and you can see again that that follows the shape of the part or the reference surface. I've got zigzag with lifts, and I'm going to do a scallop type cut, tool position tangent to. So while we're in here, we can show our body, hide the revolve. We've got projection vector towards drive. In this case, normal to drive also works, but while we're in this valley here, this cutout, we're sort of in a cavity. So I went ahead and went with the towards drive. Tool axis is normal to drive. And then I've also, under non-cutting moves, turned on the smoothing. So we'll go ahead and generate this. And there we have it. So if I go in here and select on this toolpath here, you'll see that our tool axis is very controlled, smooth. It's not jumping around like it would with normal to surface. It's able to come into the top area and machine. It's just able to follow the entire part all the way around, fairly smooth. This isn't the only toolpath you could use. You could also use a contour profile on this part and run swarf based normal to the walls, but this being able to run your tool axis based on the drive geometry is a very handy tool. You do have, if you get modeling, you have a lot of tools in order to create a drive surface. One I particularly like is the enlarge surface. When you select on a surface, it just creates an untrimmed sheet that can be easily dragged. So, it's possible that we could have even used this. It's getting a little bit of a curl there, but You just have a lot of surfacing tools in NX, a lot of power and capability when it comes to surfacing and building reference surfaces. All right, well, I appreciate it, and that is multi-axis surface area with drive or tool axis depending on the drive geometry.
All right. Let me look here and see if we have any questions. All right, so if you have any questions, feel free to type them in the chat and let me know, and I can unmute you, or you can certainly email us. As I think I have the phone number here and everything. You can go to our website, and then that has all the information for contact. We have Taylor's information here. So appliedcax.com, and then you can see Taylor's phone number and email there, and he'll connect you with the right person. We will provide at least the mold part and this recording so that you can open up the file, play around with it, look at it, and also review the recording. So we'll be putting that on the website. And then also, I think we'll be emailing links. I'll double check with Bjorn. And then we will have a follow-up. There's some great things in NX11, some awesome new things coming out. So we're going to do a what's new in NX11. There's some things I'm really excited about that will save us and you guys a lot of time in machining and creating toolpaths and just some great optimization tools. So I'm really excited about 11, and we'll be able to share that with you. All right. Well, it doesn't look like, let's see, we have any questions popping up. I really appreciate everybody joining us today. Yeah, I just really appreciate your time, and hope to hear from you and any questions you might have. Oh, wait, here we go. Sorry about that. I see Anthony here. Let's see. As far as associativity, Anthony, you know, I wouldn't know how to say in relation to Pro-E, but associativity to CAD/CAM, you know, it's in most cases we're receiving you know, formats that are Parasolid and step, and then you have the ability to make manufacturing optimizations for the different stages. And then we also have situations where there are NX parts. It's very associative. I mean, if I have a customer that lets us optimize their vacuum molds. So I think that was in the last webinar I did. I kind of showed some of that. So they have some vacuum holes that are, you know, really small and deep inside of cavities. I think they're 8 thou. Yeah, somewhere. It's just incredibly small holes, and there's usually 600 to 1,000, very, very far down into the cavities. And so sometimes I have to change the the angle of the hole, so I can just go in and change it. I can go into modeling and change that hole, and then go back into manufacturing. It's updated. Just hit generate, and then here where you saw I modified this model. You know, NX was the manufacturing was aware of that and updated, said, you know, hey, you need to regenerate. There's been a change. Done. So very related. Let's see. Roughing and finishing. I didn't go over that here, but yeah, we have toolpaths that are specific to that, like facing. So we were mostly in the multi-axis. So in mill planar, you have your kind of stuff meant for roughing areas out, finishing planar faces. So lots of different ways to go about that. Wall only, floor only. You can have it recognize everything if you want. as far as if you change the order of operations, it would say, hey, there's material missing here, and I won't go there. Or you can kind of say, I want to control that and tell you if there's material left or not. And that's just in regards to having control. NX wants you to have control of your toolpath. So we try not to limit what you can do and give you the ability to say, yeah, I like that, but I want to do it different. And also in regards to if you have everything looking at the material where there isn't material, it can add time. So some customers prefer to have everything turned off and manage that themselves. And then if you make changes to, so if you have a drawing in NX, so he's asking if there's changes in fixture features, will it update in the drawings and collision verification? Yes. I didn't have it turned on, just wanted to be able to show, analysis and if your tool's too short, rather than having it suppress the toolpath. But yes, and you can even have associative shop docs. The general one is great, that's included, but there's even one if you're doing a lot of documentation where your documentation for manufacturing is associative. It's almost like setting up operations. Then you can have drawings and dimensions and different views captured, and if something changes, it retakes those views, shows the latest dimension and drawing, and then just automatically generates it, puts it as a PDF in a folder or prints it, however, whatever your preference is. But if you don't have that particular type of shop doc and you just have drawings, it's still going to update, and everything's related, everything's relative, or associative, sorry. All right, well, thank you for your questions. Awesome. All right, well, again, let's see. I just really appreciate everybody's time. I hope you learned something. All right, well, have a great day, everyone.